Hello guys, welcome back to another video. In today's video I'm back with the part 70 video for showing you the projects that I've done so far. And like I said before, in this is part 17. I don't think I said that, but this video is part 17, and in the last part video I show you half through of action detection project that I done. And in today's video I'm going to continue from half through and until the end of the project. And without further ado, let's get started. Alright guys, I'm back, and this is the project. And I think in the last part video we ended up here, and one thing to know that I'm starting to not get deep explanation into the code. I'm just going to tell you what the code is going to do, because that will going to take too much time to explain it and to make some sense. But I'm just going to tell you overall, not detailed explanation. But now let's get started with it. Okay. If I did not explain this code in the past part video, let me just quickly explain this, and I will go down after I finish this one. Basically, this code right here will going to help us to see our it will going to open some camera, and then it will going to also show the action you are taken, and then also it will going to detect and store it into NumPy array, and that will going to no, I'm sorry, this just only show us our video. It will going to open capture, and it will going to show us with the action we taken, and that's what's going to do this code. And here this, I think this help us to capture the movement we taken, and then store it into some folders. And for example, this is for pose, this is for our face movement, this is for left hand LH, and this also for right hand. And we are going to return those four captured with a list. And here we specify some variables, and this is the data path we want to store it, and this is the action we are gonna take, and this is number of sequence, and this is the sequence length, which is, I think this will go into 30 seconds and 30 movement, and then this will be 30 movement of 13 those movement, which is totally 19. 13, we have 13 sequential lengths, and for each sequential we have 13 sequences. Hope that makes sense. And here we just making a directory based on this. We are going to make directory in this folder of these folders. Under this folder we are going to create for 3 hello, thanks, and I love you folder, and we store it under this data 006 folder. And then also I think we are also going to, under each folder here we create, we are going to create a number between 1 up to 13. Here here is number of screens 13, 1 up to 3, 13. So that's what we are going to do here. And there is a big code here. I'm not going to explain this, but what we are going to do is we just open the capture here like we did here, and then with the movement display, and then also it will going to collect those movement, and then we will going to store it into each folder, each hello, I love you, and thank you folder, and then under those we have 13 another movement. We will going to store it on those numbers folders, and one folder for example in under hello one folder we are going to have 13 movement. I hope that makes sense, and that's how we are going to do with this code. And here we imported train test split, and then two categorical. This will going to help us to split our data, and I think this will going to change the the folder name into strings. I think that's what's going to do. I don't know, I'm not exactly sure. And here we just label map, we just give label map to be equal to label and number for actions, which is I think somewhere here, and we split it into label and number, and this will going to be this list will going to have, I think this maybe this will going to be dictionary. I'm not quite sure. Let me. Okay, yeah, this is dictionary, and we have label. This will going to be the value, the variable, and this will names will going to be the value. No, this will going to be the variable, and this will going to be the value. Okay, and here okay, what we just did here is okay, I think I'm not quite sure. I think yeah, we loaded our movement, we stored into our data into this project again. We just capture here, and we just again take those numpy captured data into our project by doing these types of code. And here we specified the x value and the y value, which is the x value will going to be the future or the input, and the y will going to be the label, the output we want to figure out after we train it. And we also divided into x train, x test, y train, and y test variable by using train test split that we imported right here. And then also we finished up importing data, and until here we just collecting data and adjusting something. That's what we did here, and under that we start building the model, and we imported sequential. We used sequential to build our model. To build the model we don't use a class, and we also import layers. We use LSTM and dense, and then we also import callback, and then it is tensor board, and we specified the log direction, which is a tensor board, the callback, and the path is this one, and td callback will going to be tensor board that we imported here, and log directory to be log directory this one. And we build our model here. As you can see, we have LSTM, three LSTM layer first neurons, and the last three neurons is dense, and we have 64 layers, and the first one, and so on for other. And in the we also use ReLU, the first one up to the last second one label neuron. We use ReLU, and the input is this number, and then also return sequential to be equal to true until LCM the last one to be false, and the last one dense to be the shape to be actions shape 0, which I think going to be 3, and action to be activation to be softmax, and this softmax will going to help to more than 2 classification models, and that's our models looks like. And we compile it, we use Adam to compile, and we also for our last we use categorical cross interpret, and for matrix we use categorical accuracy, and we fit our model here. I just commented out here because I think I already trained, and while I'm running this code again and again, I don't want to the model to be fit again, because I saved it after it will take times for that reason I commented out. So whenever I run all code, we're going to load it up here. So I saved the model here to be model.save. I think I have to comment out this one, but I'm just leave it here because I don't think I will come back in this project because I finished it up. But I saved this model that the model is train with the X train and the Y train, and epoch for 13 times, and the callback to be the callback we built here. And we saved our model, and here we import panda, and to be the data frame X for X in Y train, the first matrix, and the second one to be Y for Y in Y model prediction predict. Okay, we just did here, we just try to compare the predict one and the real one here, and here we say colors equal to these numbers, and if prop vis to be result action input frame, and colors I will going to take those variables, and output frame equal to input frame dot copy. And for numpy I think okay, alright, I think this will going to display the I don't know what this one code, but I think this will going to help for some code here, so that's why I think we create some function and we create some variable here, and this code will going to show us the prediction with display off in the screen. If I run this one, it will going to show popped out some camera, and if I use some things sign language, it will going to tell us it is a things sign language, and for other one also. And here's the project looks like, and I hope you find enjoyable in this video, and I hope I see you in the next part video. I hope to see you there. Bye.